This is the material I shall be using for this project, a 40 mm shaft with a 100 mm flange and a 100 by 50 mm piece of U-section. The U-section is cut by hand. With practice this method results in less material to remove than my chop saw or power hacksaw. The ends are cleaned first using a long roughing end mill, followed by a long end mill. Since the U-section is not perfect and cannot be readily squared, it is held with minimal contact. The area being fly cut shall act as a reference which shall be later used to grind the underside. A 40 mm hole for the shaft needs to be bored. The edge finder is used to locate the side of the U-section. A carbide hole saw shall be used. It is moved to the center of the U-section using the DRO. Unlike the high-speed steel versions, these carbide hole saws produce an accurate sized hole. Here I am using the boring head I made way back in 2006, to make a 55 mm counterbore. The counterbore shall house this angular contact bearing. I had to widen the 40 mm hole to 55 mm for a depth of 3.4 mm. This called for numerous repeated cuts. The mill I built has a limit switch that can be set to cut power to the Z-axis power feed at a specific position. Perfect fit. The bearing shall only be partially held in the U-section. However, this is more than enough for the forces envisaged. The side, that shall become the bottom, is milled perpendicular to the axis of the bearing. Two holes are drilled where the bearing outer race shall be seated. They shall be used to eject the bearing from its housing. The U-section is held on the previously fly-cut surfaces. I need to grind a surface parallel to the seat of the angular contact bearing, where a thrust bearing shall act. This setup is a bit precarious, even though the U-section is well braced, so I take light cuts. The body is prepared for welding. The bottom reference surfaces is clamped to a smooth plate. The base part is aligned and clamped to the plate. And here it is all welded up. And the welds after some grinding. The body is held in the vise with reference to the ground surface where the thrust bearing shall act. The base and the sides shall be machined in accordance with this reference surface. The sides are first roughed out with a ripper end mill. I do not need to machine the whole side, just the height of the vise jaws. Finally a long end mill is used to finish it. Both sides and the front are machined. The sides are then ground to produce a smooth perfect surface. The body is held with the thrust bearing reference face in contact with the angle plate. The base is being adjusted so it is parallel to the surface plate, before grinding. The base is ground on the surface grinder I built. The sides cannot be fully ground as this exceeds the grinder's capability. However, I managed to grind well in excess of the vise jaw height. The internal surfaces of the U-channel are sloped and need to be machined parallel to the sides of the body. The rear bearing housing shall be fitted here. A carbide hole saw is used to bore a hole in line with the chuck bolt hole circle. This will allow the chuck retaining screws to be inserted and tightened. The angular contact bearing is seated in the pocket milled in the rear of the U-section. It shall only be partially seated, but this is enough for the forces envisaged. A roller bearing shall act between the front end of the U-section and the rear of the spindle. Since the surface of the U-section is uniform along its length but not along its width, I need to mill the top of the body parallel to the reference surfaces already created. The worm gear assembly shall be screwed to this surface.